Hi everyone, my name is Ben from Alluxio. Today I'm going to talk about how Alluxio can help you to eliminate S3 bottlenecks to scale your I/O and how you can use this to potentially benefit your Ray applications. Okay, so the problem statement, Ray is fast and you have fast GPUs. However, the data may not be fast, okay? Based on my experience working with the data modelers, AI researchers, from time to time, they only want to focus their own jobs in making the model better or making the inferencing better. They do not want to handle issues like, oh, I have to handle the data sets, or it might be too large to fit my local disk, or I'm downloading slow or unstable from the resource. They had to handle different URLs in different environments when I'm launching my jobs in different clusters or different clouds. It's handling network issues, permission issues, syncing back data from your remote storage. Okay, none of them handle issues like this. They all prefer an easy, fast, scalable solution so that they can just start to use the data in the plug and play manner. Okay, so this is where Alluxio comes. We are a data acceleration layer for Ray and for the AI workloads. You can think you have the persistent layer on S3, Oracle, Azure, GCS, even the on-premise storage like Hadoop. And then you just put this data access and acceleration layer like Alluxio, put into your GPU clusters or CPU clusters. And then you can access data just like accessing your local disk, your local mount. It gives you the feeling you are just using a NAS, but actually it's backed by a storage or a cloud storage service, buckets. Okay, that is in a very high level what Alluxio is. Just give you a feeling. This is but basically Alluxio, the sequence, if you want to use this, it's transparent and easy. Admin can just mount a buckets or multiple different buckets into Alluxio, and then I'm showing the POSIX way, okay, then you can start to use your data, which is backed in the persistent buckets, and just look like they are sitting in your local disk. And you can read data, you can write data. And remember, this is actually, just recall, this is actually not a single node solution. We are talking about distributed systems. So Alluxio is not like a S3FS or GCSFS. If you have heard these tools before, this is a distributed system that can be a few workers to thousands of workers. So that presents the unified and shared caching and data acceleration service for you. So what it means to you as an AI user or customer? Get a transparent, simple, regardless data cloud or storage you're using. No code change, no configuration change. Works with most of these existing frameworks. And the data will be available instantly once they are pushed into the buckets. No wait for data to be copied to your local storage or to somewhere. As I mentioned, this is a distributed system, so you actually get the aggregated performance. Cluster-wise, if you have hundreds of Alluxio workers, you get terabytes per second as aggregated throughput. And the time to first byte latency can be some milliseconds. I will show you the benchmark. More importantly, this is proven, the scalability is proven in production. We have a large customers running petabytes, multiple petabytes in the cache volume with billions of files and beyond cached, okay? So this is one of the benchmark. You are reading the data with six Alluxio workers where data sits in a cloud object storage. If you go to object storage directly, you get around, like for example, in this case, 7 gigabytes per second to pull the data directly from the object store. And this is about the same or slightly less than if you have one Alluxio single worker, which gives you 10 gigabytes per second. Note that this is already close to more than 80% of the utilization of the NIC, which is 100 gigabits NIC. But you have 6 Alluxio workers pulling together, you get more than close to 60 gigabytes per second. And in terms of IOPS per second is similar. Like we're able to get a 5x IOPS per second compared to one worker when you're 6 workers. And this is like almost 20x more than if you're just talking to a cloud storage directly. Latency. my favorite part. Basically, Alluxio is designed for low latency workloads. If you have really low latency, latency sensitive workloads, you want to get the data from your cloud storage fast. As you can see, if you directly talk to the cloud storage, it gives you, on average, about 20 milliseconds. This is average. If you're talking about P99, this can be 300 or 200 milliseconds. But with Alluxio, it gives you consistent, stable sub-millisecond latency for both average and P99. Proven scalability. You can run this with 1 terabytes per second with individual cluster with enough number of nodes. And the largest single cluster manages more than 3 petabytes of data. And a single cluster manages more than billion files. Why this matters? When I'm talking to people who are training their models for self-driving cars or robotics, they're often using tens of millions, 100 millions, or even billions of files, small images or video clips in their data sets. Okay. 50 production clusters deployed globally for the largest customer. Okay. So for Ray, I'm talking about Ray here today. We have an integration with Ray, and you can use our FS spec interface using Ray to talk to Alluxio. Instead of talking to, like, for example, Ray data, and we shows there's a 3.5x improvement in terms of throughput from the same region. Okay, so the transparent and easy access will enable this integration for Ray plus Alluxio. As you can see, you can have different type of frameworks here, and you can choose your favorite APIs, S3 API, POSIX-like, or Python. For Ray, we support, like, Ray basically can use any of these APIs to talk to this caching service, which is backed by the storage. And the user experience will be like, hey, I just mount this bucket, my bucket mounted into the Alluxio directory, and then the metadata, this is only a metadata operation. There's no data migration, and this can finish in a second or two. And then you can have 2 different ways. Your Ray applications can now just read from a local directory. You can view this as a PVC, persistent volume claim, to your applications, and you can start to read and write from the same persistent volume. And we also provide, as I mentioned, like you can use the S3 protocol, so you can set the endpoints to be Alluxio S3 endpoints instead of the default, for example, S3 endpoints or some other object store endpoints. Then you can still continue to use your S3 APIs to engage with Alluxio. Yeah, I want to share something fun like we're doing recently. One is we are integrating with Hugging Face. So if you have a Ray applications or some other things, you can just use an Alluxio and mount Hugging Face hub, model hub as a file system. And after this, like for example, running the first command, you can directly go to get these models, just like they are sitting on your Linux folder locally. And after that, like we also have certain optimizations to for you to load safe tensor formats from Hugging Face into GPUs. And the reason behind, the philosophy behind is we're doing some we did some analysis on the data access pattern to this safe tensor formats. So once you touch part of this, it's a format. It has actually quite a few files in the same directory for the safe tensor files. And then we can predict like what is the next one or next one for you to access. And this gives you pretty good rates to load data into your GPUs. Okay. So like for example, we enable Fireworks to load models fast to avoid these cold start problems in seconds, and we see terabytes per second aggregated throughput in a single deployment for this model inferencing use case. And for example, Salesforce, they are building a sub-millisecond latency for the agentic memory layer, where they're having these petabytes of data sitting on S3, but they want really sub-milliseconds, so we are able to help them. We have a joint white paper talking about what we do there. That concludes my talk. So we have a booth, and if you want Labubu, you can feel free to scan this and come to our booth. I'm happy to talk to you.